Yeah, let me start with introducing you, Yarden. So the most interesting thing about our speaker today is she's among the ladies who perform in a circus. And what do you understand about that? It's just a lot around physical activities and just basically circus. And the best part that really that was striking to me was that she's from CrowdStrike. And the best thing I know about CrowdStrike is they are known best for EDRs, right? And secondly, maybe I can let you to tell us more about your story and how you ventured into cybersecurity.
Yes, absolutely. Love to. Did make slides, but I forgot to put an About Me slide in there, so I'll just talk about that. So yeah, I'm Yarden. I work at CrowdStrike, which is possibly the best EDR out there, but I'm biased because I work there. But it's a really good product with a company with great people doing awesome things. And the mandatory we're always hiring, so talk to me if you're looking for a job. Yeah, I've been working there for a couple of years, working on the Windows side of our EDR product, doing Windows research and development. Before that, I worked for SentinelOne, which is an Israeli EDR company. That was my first job in the field. Strictly speaking, I don't have official technical background. I do not have a degree or any official classes they learned. I just kind of started in the field. Right now, aside from CrowdStrike, I also teach Windows internals, classes, workshops. I teach Windows internals courses in conferences and other places together with Alex UNESCO, if any of you heard the name. We have a few public workshops every year. And other than that, I'm a circus artist. I do aerial arts, meaning I hang 5 meters in the air, doing splits and saltos and all sorts of funny things. I perform in the circus, or I used to before COVID came and disrupted things. I teach circus classes. I've been teaching for a few years. I did go to circus school, no engineering school, but I did spend a bit of time in circus school. And I used to work as a pastry chef too. That's another part where I do have a bit of official education. I did go to pastry chef school as well, and I did work in that for a while. And decided it wasn't the line of work for me, so now it's back to a hobby, but feel free to ask me any pastry related questions you might have. I would love to rant about cookies or bread or baking. I actually did that a few days ago in PancakesCon. I gave a talk about Intel CT and French baking. So feel free to ask me about that too. My technical background, like I said, I do not have a degree. I don't have any official technical background. I studied a little bit of programming in high school, but that's about it. When I had to go and find my first grown-up job, I have a lot of friends who work in tech, who are way, way, way more technical than me, who have been doing technical things, since they were little kids, and I didn't. But I started looking anyway. I just sent my resume out to all sorts of companies for very entry-level jobs, for support roles, for QA roles, for things where you don't necessarily need very strong technical background. After enough searching, I got accepted into SentinelOne as a QA to test their product, to basically poke it and see how it can break. I did that for a while. While I was there, I learned some Python. I learned the automation infrastructure. I started doing more automation work. And I learned the product. I slowly learned some programming and some research skills and just moved inside the company. At some point, I moved into the research team and kind of learned whatever I needed to know in that team. It was a really nice team. They spent a lot of time with me, helped me, mentored me, and they taught me a lot. And that's kind of how I started out. That is my background. A lot of really nice people helped me to get there. And now I try to do that for other people. I try to teach and help and share knowledge and answer questions. So like outside of this workshop, I do all sorts of other workshops, and also I'm always at least semi-available on email or Twitter to help anyone who needs it. So feel free to ping me or ask me for any ideas or questions or advice. I'd be happy to help. So that was me. Now let me share my screen. We can start the workshop. Our workshop is going to focus on the first steps of how to debug Windows applications. For now, user mode applications, what we can see there, what can be interesting, a bit of learning how to work with Windbag, which is the main Windows debugger. Is if you're going to do any Windows research, Windbag is an absolutely necessary tool to have. And if you know how to use it well, it will make your life so much easier. So it's a great, great, great tool to learn. I use it all the time. That's one of the first things I open when I turn on my computer. So yeah, Windbag is the built-in Windows debugger. When you install Windows SDK, it comes built in with it. So you can just go on the Microsoft website and install the SDK, and you'll find Windbag installed on your machine. I'll try to be available in chat. So you'll have Windbag, and you can open it. Just search for Windbag. You'll see you have a few installed here. This is a 64-bit machine, so I would usually use the 64-bit debugger. Computer has not been the most cooperative these last few days. You would sometimes want to use the x86 debugger if you are debugging a 32-bit application. Like a lot of malware is still written as 32-bit apps, so you would sometimes want to use this debugger for 32-bit applications. I don't find myself using it all that often. And these two are for ARM processors, so unless you have Windows on ARM, which I think about 3 people in the world have working right now, you will not really be using any of those debuggers. So mostly the x64 one, if you have a 64-bit machine, would be the most useful one. Now, that's the old school debugger. Usually my everyday work, I use the newer Windbag, which is called Windbag Preview. I would have loved to do all the demos in this workshop with Windbag Preview, but I'm running with this machine. For some reason, Windbag Preview would not get installed. I highly recommend installing it if you're going to be debugging anything. You find it in the Windows Store, and it looks so much nicer than the old debugger, and has all sorts of cool features. I wish I could show it right now, but this computer has been very uncooperative in the last few days, so we'll have to make do with the old debugger. Now with Windbag, you can debug user mode applications, like Notepad, like CMD.exe, like anything running on your machine or anything that you're trying to look into. You can debug an application from the second it starts running. Basically, run the application under the debugger, or you can attach to an existing process that's already running. That's for user mode. You can also debug kernel mode with Windbag. You can attach to a virtual machine or to a remote machine, or you can debug your current machine. If you debug your current machine, things will be a little bit different because you can't actually run code through the debugger when you debug your local machine. You can only use it to look at memory and structures and do forensic work. Because nothing can run while debugger is broken in, so you can't debug what is actually happening on your machine through a kernel debugger. The last thing is looking at crash dumps. It can be either application crash dumps or memory dumps that get generated when your machine crashes. It's very easy to recognize when your machine crashes. You get a blue screen death, or it can be green, it can be pink. You can configure it, but every time you get a blue screen, memory dump gets written on disk, and it's written in a format that you can see that you can open with Windbag. Oh, is my sound not great? I'm not sure what to do about that. I'll try to move noisy things to other places and hope it gets better. Okay. Well, let me know if there are issues with sound, and I will try to voodoo it away. Okay, so that's what Windbag is about. Now let's open Windbag. In this workshop, we'll only do user mode debugging. In the next one, we can do kernel mode debugging. So I'm going to open my Windbag here, and we will try running a new executable. All right. So we can do either Control-E or open executable. We'll choose Notepad because Notepad is always fun. Again, this is the old debugger. So what happened for now is we opened Notepad. It mapped the first few DLLs that it imports, which we'll talk about in a minute. And it reached the initial breakpoint. When an application starts, it doesn't actually start running. It just loads the basic modules it needs to load, and then it hits an initial breakpoint. Now, if a debugger is not attached, there won't be an initial breakpoint and the application will just keep running. But if there is a debugger attached, we'll reach this symbol, LDRP do debugger break, and we'll get an interrupt, and int3 is the debug break interrupt, which makes our debugger stop running, which makes our debugger catches this interrupt, and now the application is not running until we allow it to run. Now the first thing we need to do is to configure symbols. Those symbols they give us data about the different modules. Now, when you compile a module, you also create a symbol file. It's a .pdb file that has certain information about the module. It can be a DLL, it can be an exe, it doesn't matter. Like its function names, its variable names, it's all the internal information about the application. And there are a few different kinds of symbols. There are private and public symbols. If you would debug your own application, something that you wrote, you compiled, you would have private symbols, and you could see, for example, variable names and everything. For example, if someone works in Microsoft, they would have private symbols for Notepad, for NTDLL, for kernel 32. But Microsoft doesn't want everyone to have all the information about everything. That would be pretty close to giving everyone source access to all the Microsoft code. And don't want that. No company really wants that unless they're doing open source. So instead, they're shipping all their, or almost all their modules with public symbols. Public symbols are kind of stripped down. They have some information, for example, function names, but it's missing other information like variable names or signatures of functions. By signature, I mean how many arguments the function receives, what types, like internal data structures, internal types. That all doesn't exist in public symbols. Public symbols are stripped down. Now, to get the symbols, we need to go to the Microsoft symbol server, which the debugger knows how to do. We just need to tell it where to get the symbols. And there are a couple ways to do that. One is through .sympath. Now, .sympath shows us what path we're going to be using to search symbols. Now, in this case, it tells me expanded symbol search path is this, which is great. This is exactly what I need. I also have it in the slide. https://msdl.microsoft.com/download/symbols. Now, let's say I don't have that path. I need to add it. And I can add it either by clicking Control S to open the symbol window, and I can add it here. Or I can run sympath plus and put my path here. Now it gets added to my symbol path. And to load all the symbols, all I need to do is .reload. This will reload everything that's needed, or I can do reload/F to force reload all the symbols. This will take a minute. So now I have all the symbols I need for Microsoft modules. Now you won't always have, sometimes you won't have any symbols at all. Some Microsoft applications have no symbols because they don't want you to know anything about it. They don't want you to research it. They don't want you to look at it. And of course, non-Microsoft things will often not have any symbols. Like if you're going to be analyzing malware, it will probably not be shipped with a symbol file because that would make no sense. And then you can still debug it. You can still load it in the debugger. You can still run the malware under a debugger, but you'll have a much harder time debugging it because you won't really have anything to start with. It has no symbols. It doesn't tell you anything about itself. So you kind of need to start from scratch and figure out everything for yourself. Public symbols are there to help you out. Now, once we have our symbols loaded and we have our app running, or at least started running, we can look at what modules it loaded. It tells us a few here, but there are ways to get a bit more information. The old school command, legacy command, would be lm, loaded modules, which tells us the name of the module, its start address, its end address, and what symbols does it have. For example, we can see that one Microsoft module, Combase, is shipped with private PDB symbols. That's not by mistake. That's because Combase is, it's a COM DLL. It is so complicated. COM is really terrible to work with. That even if you had the source code of Combase, it's hard to debug. So Microsoft decided in this case to ship private PDB, so it's usable in any sort of ways, because with public PDBs, Combase is really, really, really impossible to debug. So for this one, we get private PDBs. Now that's the legacy way of looking at loaded modules. But what Windbag got in the last few years is there was a lot of work done on Windbag. It received a lot of improvements. And one of those things is the debugger data model. That's a data model that really enhances Windbag. It gives you a lot more information, a lot more choices. Gives you NatFis, which is a nice way to parse and look at data structures. If any of you debugged anything with a Visual Studio and you have this little locals window at the bottom where you can see all your variables, that's NatFis. So now the debugger has that too. You can see it way more nicely with Windbag Preview, but we have to make do with the old debugger for this one. And you reach the debugger data model through the dx command. You can just run dx and it will show you all sorts of options. And one of the things dx has is it has some really fun built-in registers. For example, cur process, which doesn't dump the kernel structure of the process. Instead, it dumps some crafted information about the process we're currently in. Now, in this case, we only have one process to look at, which is Notepad. But if you're running like a kernel debugger, you would have a lot more processes. You can look at all the processes in the system. So cur process shows us the process we're currently looking at. It tells us its name, its ID, the handle for it. And we can also look at its modules. It shows us all the modules, and these are all clickable. We can get more information about them through either clicking on them or accessing them like we would access an array in C, because it is an array. For example, we want to look at module B, which is MSVCRT. So we get the base address, the name, and the size. Now, what we would normally get is something inside of contents. For some reason, it doesn't work on legacy Windbag. I didn't get it to work on Windbag Preview. So because I could not get Windbag Preview to work, I added some screenshots of what we can do with a new Windbag. And this syntax takes a bit of getting used to. The syntax is using something called link, which is another part of the debugger data model. It's an SQL-like addition, which means you can take all these objects, because what we receive here through modules, for example, is a data structure. It's an array. And like an array, you can query it, you can iterate it, you can do all sorts of things with it. And everything in the debugger data model is an object, so we can treat it as an object. So what I did here is taking module number 5 in whichever process I was looking at. And in this case, module number 5 was, I think, kernel base. I dumped its contents, which would normally show me a list of all sorts of things in Windbag Preview. And one of the things in its contents, one of the fields of the object is imports. Now in imports, showed me all the DLLs that module imports from, because because everything in Windows imports functions from other modules. And I'll talk a little bit more about that. But that imports from all sorts of DLLs. One of them is empty DLL. And I can go and look at the functions that it imports. So I could just dump all these functions, but that gave me a slightly ugly data structure because it had all sorts of information that wasn't necessarily relevant. So I did a select to only pick some of the fields. And the fields I cared about were import name and address. So I selected both of these fields into a new data structure. This is an anonymous data structure, that new with curly braces. That's how I defined an anonymous data structure. Contained the import name and the import address for every imported function in from NTDLL. Then I ran that with -G for graphics view, and it dumped this really cute table with exactly the information I was looking for. So that's a really fun way of seeing what imports, what functions this mysterious module, which I can tell you is kernel base, imported from NTDLL with the debugger. We can also do the opposite thing and seeing what functions this module exports. So again, we look at this module, the same one, look at its contents. It has an exports field. And now for each export, I select the same two things, the name and the address. Oh, here it should be f.name. I mistyped here. I select the name and the address of the function. So now I get this table showing me what exports kernel base has. Now just a few words about imports and exports. User mode applications on Windows can't really do anything by themselves. If you're writing a user mode application, it can't access the disk, it can't do network operations, it can't do memory operations, it can do very little. It can do some math by itself and not all that much more. The only way it can do all these things, for example, access the disk to write a file or read a file, is by asking the system to do it. All of these things at the end of the day, or almost all of them, happen in the kernel. The kernel is the only part of the system that can access the disk. So if a user mode application can't access the disk itself, it needs to ask the system to do it. It does that through a thing called system calls. And still, apps don't usually do system calls themselves either. They get helper functions to do that for them. For example, if my application wants to access the disk to open a file, it would normally call create file, which is a function that my application doesn't implement itself. It's a function implemented in kernel 32 or kernel base. So to use that, my application needs to load that library. All these DLLs are actually just external libraries. It needs to load kernel 32 and ask kernel 32, hey, I want to call create file. Now, kernel 32 still doesn't talk to the kernel. Kernel 32 needs to call a function in kernel base. So it needs to load kernel base into the process and then call function in kernel base. And then kernel base still can't do system calls and talk to the kernel itself. It needs to load ntdll, which is the basic Windows library, which implements system calls. So it needs to load ntdll into the process and call a function in ntdll, which will talk to the kernel. That's we can follow that path in the debugger. We'll do that pretty soon. But that's why we have all these loaded modules into the process, because the process itself can't do anything without asking the system. And all these loaded modules are helper libraries to help it do things, to help it open files, to help it make network operations, to help it access memory, like allocate memory or change memory protection. All of that is done through these helper libraries that eventually talk to the system, talk to the Windows kernel to ask it to do things. And it can agree or not agree to do them. That depends on the Windows security model and all sorts of other things. So any questions on anything so far, on modules, on basic Windbag usage? Okay. So we'll move on. Now, Windows process is not the basic unit of operation. The basic unit of operation on Windows is a thread. Every process has to have at least one thread. A process with no threads just can't do anything. Process in itself doesn't execute code, only threads do. So a new Windows process will always have at least one thread. And usually there will be multiple threads, because we'll have one thread that does one thing, another thread that is, for example, waiting on some objects, because you often can't have multiple processes accessing something at the same time. Like you you might not be able to have two processes running to the same file at the same time, because that would just make a huge mess and probably corrupt the file. So you might have a few threads waiting on some object, waiting to get access to it. And you don't want your main thread to be waiting on an object, because that completely blocks the application. So you would have multiple threads, and usually not even know it. So of course, with Windbag, we can also look at the threads in the application with band threads. It shows us this parsed view. A bit slow today. So we can see that this Notepad process that barely even started running already has 3 running threads. And gives us, for example, the address of the tab. Now the tab is a thread environment block. Every thread has one, and it keeps the necessary information that the thread has to have to execute. For example, where its stack is. The stack is where the thread keeps its information, keeps its local variables, keeps its return addresses, so it knows where to return from a function. So the tab has the stack base and the stack limit. Now that's one way to look at the threads. Another one is with dx. We have a few ways. We can either do cur process.threads and see all the threads in the process, or we can use another built-in variable, cur thread, and only look at the current thread. And that again gives us a nice parsed view of the thread. And again, this is an object. All these blue ones we can click on. For example, we can click on stack frames to see the stack. The stack shows us where this thread came from. For example, the current thread is currently in LDRP do debugger break, which is not surprising because that's the initial break of the process. And we can see where it came from. We read a call stack backwards. So once LDRP do debugger break returns, it will return to this address inside of LDRP initialize process. And when that returns, it will go back to this address in LDRP initialize, and so on and so on. You can see that these 2 threads are worker threads. So we can click on them and see their call stack, which is different. This call stack is a worker thread that is waiting on something. Yeah, it's currently in NT wait for work via worker factory. Now this thread is probably not actually in this address. This thread is probably in kernel mode right now, waiting on something. But because this is a user mode debugger, we can't see kernel mode stacks. If we, in some other session, do kernel mode debugging, we can see the full stack, including kernel mode. But we actually can see threads user and kernel stack through a different tool called Process Hacker, which I'll show later if we have the time. So through this, we can see all sorts of information about the thread. We can see its registers. Yeah, the values of all its registers, which is pretty useful to have in certain cases. We can click on environment, see its environment block or the tab. Then we can investigate the tab. There are a lot of interesting things here. For example, WoW32 is a very legacy kind of thing. We have a few interesting flags here. We have the ID of the current thread and the current process. In general, a tab is an interesting thing. Now, every thread has a tab, and every process has a similar data structure, that's one per process, called a PEB, a process environment block. That's one way to look at all of our threads. And now, why would we want to look at our threads? Because first, it's interesting. We can do all sorts of stuff with threads. One thing is if we're debugging an issue, an application is stuck, it's not doing what it's supposed to do, we're not sure why. We can dump the threads and see maybe one of them is waiting on something, waiting on some file, waiting on some object that is not being released. So the application is stuck, waiting on that object. So you might know what the problem is. Maybe we suspect that someone is running malicious code inside of our process. One way to inject code into a process is to write some code inside the process memory and then create a new thread that will run this code. So we can dump the threads, look at their call stack, see if any of them is running something that we don't think it should be running. Maybe it's running a piece of code that doesn't have any symbols. Like in that, if we don't have symbols, we'll just see an address here. Maybe it's running a piece of code that's not inside of a module at all. When someone just writes code into a process, it doesn't load a module, that would be pretty suspicious. We don't expect code to run from outside of a module, except in certain cases. For example, Internet Explorer and now Edge uses a thing called JIT, just-in-time compilation. So that's dynamic code. So that's a piece of code that doesn't run as part of a module. It runs as part of independent dynamic memory. It caused a whole lot of issues. There's always new JIT vulnerabilities, and it's a pretty messy thing. But unless you expect your process to have JITted code in it, seeing a thread running code from a non-module region is suspicious, and we don't really expect that to happen. So that's one way to find and analyze code injection into your process by looking at its thread and the call stacks. Now, if you just want to see the call stack of the current thread, you can use dx with curthread.stack or dx curstack, which will show you the same thing, or you can use a legacy command, which is k. You can also do KB, which will try to show you the arguments. This works in 32-bit applications where it reads the arguments of the stack. In 64-bit applications, it's not the most reliable thing, so I would not really count on it. But if you're analyzing 32-bit code, it can come in handy. Now, one more thing that is useful to look at is objects and handles. Pretty much everything you use in the system is an object. A process is an object, a thread is an object, a file is an object, sections, ports. Almost everything is backed by an object, which is a Windows concept. Objects can be open and closed, and you can do lots of things with them. And when you use an object, you need to create a handle to it. You need to create a handle so the system knows you're allowed to access the object. It knows what kind of permissions you have for it. If you're allowed to, for example, you can have a file that as a user, you're only allowed to read, but not to write into. So the system tracks that through a handle. It also tracks if anyone is using the object. For example, you can't delete a file that has open handles to it, because then someone might try to use the file, but the file is gone, and that will lead to all sorts of issues in the system. So it also helps track who and what is using that specific object. And there's a few ways to look at handles and objects. My favorite one is with dx. In per process, we have IO, which, it doesn't work in user mode, it only works in kernel mode. But through that, we can see what handles the system, what handles the process has. If you have Windbag Preview, you can try this one. If you know how to attach a kernel debugger, you can also try this command and see what handles the process has. If you have a handle, you can run bang handle. I think bang object doesn't work in user mode. Yeah, it doesn't work in user mode. Only in kernel mode. But if we run bang handle, that does work. That shows us all the handles that our current process has and what kind of object they are for. For example, handle 4 is for an event object. Handle 18 is for an IO completion port. Handle 40 is to a directory. Handle 21C is for a thread. The annoying thing about bang handle is it doesn't tell us, for example, which file the handle is for. You can see that in kernel mode through curprocess.io handle that tells you what file, but bang handle doesn't. It just gives you general information. But you can still get some information from it if you see all sorts of object types here that you wouldn't expect. It might be worth looking into. And later we'll see what other user mode tool you can use to get some more information about the process handles without attaching a kernel mode debugger. So a few useful commands for Windbag. For code execution, use F5, F10, or F11. F5 just tells the process, keep running until something tells you to stop. F10 is take one step, but do not go into functions. Just if you see a call instruction, just step over it. And F11 is very similar, only it will step into functions. If it's a call instruction, it will step into the function. And we have a few commands to view memory. D means dump. So you can dump 1 byte, a word, a D word, or a keyword. The syntax for that is, for example, dq space address. And then it will dump a keyword in that address. We can use DPS to tell us, hey, I think this is a pointer to some symbol. So dump everything in this address as a pointer and tell me if there's a symbol for that. I'll show an example for that. See. Oh no, that would be a function. Well, here I'm dumping function code, so it's not pointers. But if this was a pointer to some symbol, then right after it, we'd have the symbol name. But the way to dump this, since I know this is code, I can dump it with U, meaning unassemble. And it will show me the parsed code here and the symbol that matches it. So these are for dumping general data. This is for dumping symbols. These, the C, D, S, and the uppercase S are for strings, and U is for code. Now, the last thing we need to start debugging is knowing how to set a breakpoint. Setting a breakpoint is very easy. We do that with BP. And we can do BP address or BP symbol. And we can also do conditional breakpoints or give extra commands to be run when a breakpoint is hit. But in our case, we'll do a very simple breakpoint. We'll pick kernel 32 virtual alloc. And here it's not virtual alloc, it's virtual alloc stub. Because kernel 32, for historical reasons, has to export a function called virtual alloc. But to start cleaning up some of the clutter, because kernel 32 became a really, really busy function, a really busy module, a lot of the functions are not implemented by kernel 32 anymore. They're implemented by another module. So kernel 32 has a lot of stub functions right now. So you can export the function, but then when it's called, to just redirect it to the correct module. But we'll set our breakpoint on virtual alloc stub. And we can run BL to see our active breakpoints. Okay, so now we'll press F5 or run G to tell Notepad, okay, keep running until you hit that breakpoint or something happens. Or is it not calling virtual alloc? Let's see what function does call it. Okay. I set a breakpoint on NT allocate virtual memory, which is where I wanted to end up, just so I can look at the stack and see what calls it. Oh, it calls kernel base directly. Okay, so we'll set a breakpoint on kernel base. I'll run BC wildcard to clear all my breakpoints and set a new breakpoint on kernel base virtual alloc. That's the module that actually implements virtual alloc instead of kernel 32. So new breakpoint, we can see that we set this new breakpoint. And we told Notepad to keep running until it hit it, and it got hit immediately. Now we can run K to look at the stack to see what led there. So we have quite an impressive call stack here. A lot happened until a memory needed to be allocated. And now we want to see what happened. We want to debug our function. And of course, we don't have source code access. If we had source code access, we could look at the source code, but we don't. So instead, we need to look at the assembly, which is here. We can click the disassembly window. We can put it here on the side. We have this pink line marking where we currently are. And now we can start stepping through the functions. Stepping through the function. You can see this is a pretty simple function, so it won't be too much to step in. Now we take it step by step, running every instruction at a time. If we're not sure what's going to happen, for example, in this jump, we can do R to dump all of our registers. See, then with this, it's going to test if RCX is 0. We can dump the registers and see that no, RCX is not 0. So we will not take that jump. And we can keep walking through this function until we get to this call instruction. This call instruction is calling an import. We know it's an import because it dereferences something. It dereferences something from a function table. Or underscore imp. This is the symbol for an import. NT allocate virtual memory. Now I can press F11 to step into the function. If we don't want to see what is happening inside NT allocate virtual memory, we can use F10 to step over and just see the return code. But in this case, I do want to step into NT allocate virtual memory. So we'll do F11 or T. And now we're in a whole different module. Now we're inside of NTDLL because NT allocate virtual memory is an import from NTDLL. Anytime you see a function starting with NT, it is probably inside NTDLL. That is how Windows marks system calls. NT something would be a system call implemented in NTDLL, almost always. So this is an extra short function because what this function does is it asks the kernel to please allocate memory. That's what this syscall instruction is. Syscall jumps into kernel mode. And inside kernel mode, we'll end up in the same function, in a function with the same name, NT allocate virtual memory, only implemented in NT. Now, NT is the module for NTOS kernel, the module that implements the Windows kernel. Now, because we're doing user mode debugging, we can't step into the kernel. So we can just step through this function and see the return value. But here for the system call, we store RCX in R10 because it's going to be run over. We put 18 in EAX. The reason we do that is because every system call has an index that tells the kernel what system call we're actually doing. And in this build of Windows, the index for NT allocated virtual memory is 18. So we're putting 18 or index in EAX. And we are doing our syscall instruction. Now, again, we're not in kernel mode, so we cannot see any further than this. NTDLL syscall is as far as we can go from kernel mode, but we can see what the return value was by either running R, or since we know return values are in RAX, running R, RAX. Show me the value in register RAX. And it's 0. Now 0 is a good thing because return values for system calls are empty status values, in which success is 0. So if we run our ret, we are back in kernel-based virtual alloc because we finished running NTDLL. At that point, not all that much is happening in the rest of the function. It's just cleaning up and returning. So we can press F5 to keep running. And of course, that's a pretty simple-ish debugging scenario, but there isn't all that much to it in a basic level. If you want to see the execution of an application, that is pretty much what you'll do, only most of the time it will be slightly more complicated scenarios. And there you might need stuff like conditional breakpoints. You can use BP/W to give a DX command here. Like this case will only break if the ID of the current thread is 5. For example, if we have a bug or anything that only happens in a certain thread, we can make sure to only break on the function if we're running in the context of the thread that we want to use. That's for breakpoints. Now I'll show a few things for how to see some of the information without Windbag, without a kernel debugger, without a debugger at all. And there are a few tools to use. For example, if you're not familiar with the sysinternals tools, they're great tools written and maintained by Mark Rusinovich, who is now maintaining them as part of Microsoft. They're really, really useful. There are a few dozen tools there to do all sorts of different things, to see all sorts of different things. They're great forensics tools. But another tool that I use a lot is called Process Hacker. We can run it. Ryan is admin, so we get some more information in there, because when Ryan is admin, we get some fun information. And this is its main view, shows us all the processes in the system with all the correct hierarchy. That I can see that Zoom has actually 3 processes. Here's the main one. It has a child process, and that has another child process. Double click it. Let's choose PowerPoint. You can double click PowerPoint. First, we have the general view. Tells us the full file name. Tells us what the parent is. The parent of a PowerPoint is Explorer exe with this ID. Tell us which directory it's currently in. And we have mitigation policies here. Now, Windows has a lot of different mitigation policies that can be enabled. There's like a few dozens of them. Most applications only enable a few. And we can see which applications enable which mitigations. For example, you will mostly see ASLR being enabled. ASLR is a mitigation in which modules don't have fixed base addresses. Module base addresses get shifted every boot to make it harder for exploits to know exactly where they're aiming. It makes it a lot harder to overwrite for example, function pointers to specific addresses because you don't know where things are going to be. If you see modules, if you see processes not enabling ASLR, that's weird. ASLR has been around for 15 years now. You would really expect everything to enable it. Control flow guard is a slightly newer mitigation, was added in Windows 8. So again, it's been around for a while. It makes it more difficult to, again, corrupt function pointers or things like that. It checks that call instructions call valid function pointers, that you're not calling into arbitrary memory into the middle of a function. Again, you would expect to see most processes using control flow guard. Unfortunately, it's still not enabled for everything. And if you have an application that was written like 20 years ago, or if you have an application that was written for Windows 7, it was written in 2010, it would not have control flow guard, but most new applications should have it. And dep is one of the oldest mitigations. Dep means that the stack is not executable. Exploits cannot, with dep, write their shell code into your stack and just run it. It used to be a very, very common technique. And dep really should be enabled by default for everything. Something not running with dep is really suspicious at this point, unless it's like an application from 1989 that you somehow got to run on your Windows 10 x64 machine. So that's first. Then we have a lot of tabs here. We have threads. You can see a PowerPoint has a ridiculous amount of threads. We can see the start address of each. And we can double click thread to see its stack frames. Interesting thing is, well, I scan all the symbols, it will take a minute. The interesting thing is that with Process Hacker, we don't just see the user mode stack, we see the kernel stack too. Ooh, I picked a bad one, it has everything. Let's see if we can find something that is currently in kernel mode so we can see the kernel stack. Where we should see the kernel stack of that one. I am probably doing something. I'm probably doing something wrong because we really should be seeing both. But I will try to figure it out and have an answer for you. Oh well. But yes, we can see the whole stack here with this. We can also see the loaded modules, which will be loaded in a second. And we can even add columns, for example, to see if modules enable ASLR or CT or control flow guard. CT is a much newer mitigation, just been shipped very recently. So, and this machine, its processor doesn't even support CT yet. So I wouldn't expect to see anything running with CT at this point. Here we can see, for example, what has ASLR, what has control flow guard or XFG, extended control flow guard. You can see the memory. For example, this is the PEB. We have all sorts of stacks. You can see the protection of memory. Like if you see read, write, execute memory, that is a good sign that you either have jittered code or it's something weird is going on, because you shouldn't really have read, write, execute memory in your process. That could be a malicious indicator. And here you also have the handles tab, which I told you I'll show you a nicer way to see handles of process. So here we have the handles tab, which tells us not only what type of object the handle is for, it tells us the name of the object, and it tells us what rights the process has to the object. Right? We can look at all the files it has handles to, and what access rights it has for the files. And a cute little trick is if you've ever tried to delete a file and the system tells you you can't delete or rename this file because someone is using it, and you have absolutely no idea what is using the file, you can go into Process Hacker, do Control F, search for, say, Notepad exe, and search for a name of a file, a path, anything really, and see what is using this file. If you don't want it to use it, you can press it, click delete, click the delete button, and the handle will close. And then you'll be able to delete your file because nothing has open handles to it anymore. Now we're pretty much out of time, but the last thing I wanted to show is that Process Hacker also has a network tab. Shows you all the active network connections, which is a great forensics tool because you can see, you can go over this and see what has active network connections and should it. For example, it makes a lot of sense that Zoom would have active network connections because of course it does. So does Teams, which for some reason is still running on my machine, no matter how hard I try to kill it. PowerPoint doesn't seem to make all that much sense, but I use PowerPoint with my OneDrive. I save everything on OneDrive, so it does make sense. But you can go over this tab and see if something is making weird network connections to weird servers. Owner, the ones that have owner are services or processes that run through a service. This is the service name. You can go over that and see if you're finding anything weird or suspicious or just something that doesn't make sense. You also get the remote addresses, so you can see if there's some IP here that you, for example, recognize from some sort of deny list, something that really shouldn't be used. So that's another fun forensic thing. So this was a pretty brief overview of all of that, but I really wanted to show all of this. Let's see, I see there are a couple of questions. Try to answer them. Okay. So the question, are the two worker threads we had at the beginning of Notepad something that has to do with process creation? Possible to see what is responsible for the RTL user thread start call in their call stack. So RTL user thread start is just an entry point for threads. That's the first function that will be called by the system when the thread starts. So to see what's responsible for that, we'll need to talk about the loader, the process loader in the kernel. But you can't really see that through Windbag. You kind of have to go dig in IDA or in Windows documentation to figure that one out. Windbag will not really show that because it's not a direct call. It doesn't go in the call stack. Once RTL user thread start returns, the thread exits. It doesn't have anywhere to return to. And the two worker threads are, they are in a way related to process creation, but you won't always see them. It depends on the specific process. Some processes will only start with one thread. It's related to the way Notepad starts, but you won't always see them. And in this case, they're not like super interesting thread. They're not doing all that much. Is malware and RE same to forensics? Well, RE stands for reverse engineering. Reverse engineering is just a tool. It's one skill. It's not the only needed skill, and it's a skill that you can apply to very different things. For example, reverse engineering the Windows kernel, which is something that I do as part of my work, is very different to reverse engineering of malware. As for example, a Windows kernel is a huge binary and super complicated, and it changes all the time with every build. But it does have symbols. It is partially documented. However, malware is usually a much smaller set of code. You can't really reverse engineer the whole Windows kernel. People did do that. They wrote React OS. It's like a decade's worth of work. Reversing, oh, sorry. Reversing the whole code in a malware is much more achievable, but, oh, sorry, I'll just, reversing the whole code of a malware is much more achievable, but with malware, you don't get any symbols, you don't get any hints, you don't necessarily know where to start. A malware can be packed, it can be obfuscated, because a malware will usually try to prevent you from reverse engineering. So reverse engineering is one skill, but it won't necessarily be applied the same way to different things. Like with malware, sometimes reverse engineering is not necessarily the best way to go. Sometimes you just want to start by running it on a virtual machine with tools like Process Monitor to just get a sense of what it's doing, because it will make it, somehow will make it really difficult to reverse engineer. I hope that answered the question. How do you show the process protection level in Process Hacker? By process protection level, do you mean integrity level? I mean, like, is it running in low, medium, or high integrity? I mean, a few things. I'm not, if you can clarify. What's the difference between Process Hacker and Immunity Debugger? Well, they're two very different things. Immunity Debugger is closer to Windbag. It's a debugger. It allows you to look at memory, to step through code. I personally haven't used Immunity very much, so I can't say too much about it. But you can use Immunity instead of Windbag if you prefer it. It gives you relatively similar things, and it's meant for the same purpose. Process Hacker is not a debugger. It's not meant for debugging. You can't step through code with it. You can't put a breakpoint and see what a specific function does. It's more of a tool for general information about the system. And it does give you a lot of information about the system, but you can't really analyze a specific application with Process Hacker the same way you do with Windbag. And can you use Windbag for RE? I would not recommend it because looking at code with Windbag is not ideal. It doesn't give you the best view. It doesn't give you the same abilities as things like IDA or GitRA or what's it called? Binary Ninja. Sorry, I forgot the name for a second. Those tools are meant for reverse engineering. They give you, for example, if I open my IDA here for a second. IDA, you can use IDA as a debugger. It's a bit of a difficult one. It's a bit of a difficult debugger to use. I don't use it as a debugger too often, but IDA has, for example, a graph view to see what leads to what. With Windbag, you kind of need to, follow the jumps. Oh, sorry, I forgot to share my screen. So IDA shows you this nice graphics view where you can see that this jump leads here, and this one branches out and can go either here or here. With Windbag, you kind of have to do all of that manually. It also has nice color highlighting. You can double click a function and reach that function. And IDA also has a decompiler where it will show you functions in a view that is much closer to source code. It doesn't look exactly like source code. You do need to kind of work with it, rename variables, set the correct types for everything. It is way, way, way nicer than what Windbag shows you. And IDA has a lot of features. How to use IDA is a completely different skill. Binary Ninja and Ghidra they give you similar things. And for static reverse engineering, Windbag is not the best tool. Windbag is a better tool if you want to dynamically analyze something and step through the code and see what the code does. If you want to get like static reverse engineering is a different skill, I would not use Windbag for it. What are some of the careers and jobs one might apply in the future after gaining forensics and RE skills? That very much depends on what you're after, what you enjoy doing, and where you hope to get. But if you have forensics and RE skills, there are a lot of jobs you can go to. There are a few different directions. If you enjoy coding and development work, you can learn how to code in whichever environment you're comfortable with. It can be Windows, it can be Linux, it can be Mac, and go for development roles in a security company. That's what I'm doing. I mostly do development work. That's a big part of my job. You can go into threat analysis, where you hunt down common threats, new threats, analyze them, do the research work that is both technical and not necessarily technical to, for example, try to attribute where this came from. Is it related to other malware families? Did it come from a nation state? You can do malware analysis. Lots of companies have malware research and analysis roles. People to analyze new malware, see what it does, write or recommend ways to detect it or prevent it, or communicate that information to customers, or write blog posts, or release, well, not release notes, write like technical papers about what this malware does and how to protect yourself against it. Basically, forensics and RE skills are very, very, very useful skills to have that can be applied in almost any technical role. So it really depends on what you enjoy doing. And depending on what you would like to do, there are additional skills that would help you get there. But these are good skills for pretty much anything. Okay, next one. How did you go about learning Windows internals? Is security research a viable career for people to get into still? Well, the answer for the last one is absolutely. There's always more research. There's always more research to be done. Security research, in my opinion, is a great career. There are lots of open roles. There are always new companies. Current companies are always hiring. I don't know a single information security company that isn't hiring right now for pretty much every role. I'll say that the most difficult part in this industry is to get into it. The first steps are hard. A lot of things are not really documented or not easily accessible. It was very hard for me at first to figure out what I don't know, what I need to learn. That was the hardest part, understanding what I need to learn, because I'm pretty good at learning. If you give me a topic, I will find a way to learn it, but just finding out what I don't know was the hardest part. And it can get really confusing because information security is not one thing, it's 100 things. It can go into 100 different directions, which will all be information security. I do my own little corner. I do Windows kernel research and development. If you put me on a Linux machine, I'm lost. If you ask me to do networking, I don't know what I'm doing. And like, I have never learned networking. I don't know the first thing about networking. I don't know how botnets work. I have my own skills and my own experience. And I got into Windows internals honestly because that's what the research team in Central was doing at the time. That's kind of what I started with. We were doing a few different things, but we had one project that really needed some hardcore Windows knowledge and development. And I just took that one. I was like, I'm going to do this. And I just picked that almost at random. I enjoyed it, I liked it, and it gave me a place to start. The most important thing is to find something to start with that you're comfortable with, that you're excited about, and just run with it, because there are no wrong answers. Once you have something to start with, you can start finding out the right questions to ask, the right people to talk to, the right resources to use. And from there, it gets a little bit easier. Once you get those first few people who will help you out, things get easier, and you kind of find where you want to go, because there are a million branches you can go to. And you just kind of need to pick one and start going with it. And of course, if you're interested in anything that I'm familiar with, which will mostly be Windows and a few close areas, I would be more than happy to help, or point you in the right direction. And yes, I absolutely recommend security research as a role, as a career. So it's a great career to have, in my opinion. Yeah, I'll open the stage for questions or comments. Oh, how can we reach you? Yes, absolutely. I will type it in the chat. I'm reachable mostly by either email or Twitter. My Twitter is this, and here is my email. I would be happy to feel free to reach out. I'll say that I have a lot of things going on, so I might not answer immediately, and I have badly managed ADHD, so sometimes I really want to answer someone, or I think I answered them already and I didn't. So if it's been a week and I didn't answer you, feel free to ping me again, ask what's going on. Because I am not ignoring you, I most likely marked it as to answer later and then got distracted. So feel free to remind me. Can IDA be used in virus research and analysis, or even for RE? Absolutely. IDA is a tool for reverse engineering. That is the goal. That is the purpose of IDA. You can reverse engineer anything there, and yeah. Yes, in my heart, I answered you. That doesn't always translate to reality. And so if that's the case, I apologize. So yes, IDA is a great tool for virus and malware research and analysis. I will say, if you are analyzing viruses or malware, I highly recommend doing that inside of a VM. Obviously, if you're going to run them, please do run them in a VM and not on your host. And there have even been cases, very specific, very rarely, that's probably not going to happen. But there have even been cases of malware abusing analysis tools to run code in your machines, so just be careful with that. Yeah, there are great resources on how to do malware analysis with IDA, with Windbag, with different tools. If anyone's interested, feel free to ping me and I'll send you some. I haven't done malware analysis in a long time, but IDA is a great tool for that. Any other questions, ideas, suggestions, requests? Oh, and something that I will link here. Some time ago, I posted a blog post about how to use the debugger data model. And I also gave a short talk about that in Upcode sometime last year. So let me just find the links. Yeah, I can't find the Upcode talk now, but I can find it later. It definitely exists on YouTube. And anyway, I sent the blog posts. Do I do any mentoring? I would really love to do some mentoring. Fortunately, it doesn't really fit my schedule because full-time mentoring does take a lot of time, and I don't want to volunteer to mentor someone when I can't give them all the time and attention that they deserve. I'm happy to answer questions and try to give as much advice as I can. Fortunately, I can't do like full mentoring right now. So I apologize for that. And yeah, I'm really happy to see people excited about Windbag. I love it. I think it's a really, really awesome tool. And I'd be happy to, help you with anything I can around it. Do try. Oh, thank you, Evelyn. So yeah, if there are no more questions, I'll let you have the rest of your evening back. I know it's starting to get a little bit late. Will my career ever be replaced by AI? Seeing where AI is right now in the direction. Mute everyone. Sorry. Seeing the direction AI is taking with mostly deepfake and these kind of things, I really don't see AI going in a direction where it's taking over cybersecurity careers, but you never know.
I've shared one of your presentation chat for Upcourt. Yes, so maybe each of us who's in this session can look into it. But thank you so much. This has been a very insightful session. And I don't do much around Windows internals or Windows Windbag. So I've learned something at least today. So thank you so much. And I believe each of us has learned something, and it's quite something really. And we wish to have another session for the same. Yes.
Yeah, I'd love to do another session. I kind of, went off what I thought would be helpful for this one. But for the next one, I'd be more than happy to get from everyone in the session ideas for things that you'd like to see in the next one. I'd love to tailor it to what interests you and what you'd like to know. So feel free to talk to me. And yes, go be Windows gurus, go be debugging gurus, go be InfoSec gurus. InfoSec always needs more people.
Yeah, for sure. So I think thank you so much, Madam. We look forward to another next session, and maybe we can have a restful evening for everyone else. Thank you, everyone, for attending also, and enjoy your time wherever you are. Yeah. Thank you so much.
Thank you so much for taking the time to listen to me. You're all awesome. And have a great night.
Yes.
Bye.
a good day.